Hello there. Today we will discuss about advantages of digital over analog signal processing. That means we will use digital signal instead of analog signal. Why the reasons are discussed in this slide. Digital signals can be convey information with great noise immunity. That's why we don't want the noise in our signal. That's why we use the digital signal. Then because of its information components like as byte and etc., it determines by presence and absence of a bit like a 0 or 1. In the digital signal we can generally identify where is the missing of the information by the byte extraction, which is 0 or 1. In analog signal the signal is vary continuously, but in the discrete signal the signal is in the discrete format. That is why it is very easy to eliminate the noise. Now, it enables transformation of signals over a long distance. By the digital signal processing, we can send the data or the information to a long distance. Transmission is at a very higher rate and with the wide broadband width. That's why digital signal is also used, and digital signal is moreover very secured. It is also easier to transmit human audios and video signals and other messages into machine language by the digital signal. So for those reasons the digital signal is very important instead of analog signals. Now moving to the next. Here we have the signal which is continuous time signal and discrete time signal. A signal which is denoted as xt, here xt denotes the continuous time signal, is said to be continuous time signal if it is defined as all time of t. That means the first one. In this section we can have that we have the continuous time, we have the waves in all times without missing a single second. That is why it is known as the continuous time. But in the next picture we can have that we have a value at this point, then next this one, then next this one, then next this, and next this one. That means we have gaps between times. That is why it is the discrete value. It can be as second 1, second 2, second 3, second 4, and so on. That is why this diagram is known as discrete time signal. In discrete time signal it is defined only at discrete instant of time. By those two pictures we can have that the first diagram or picture is representing the analog time because the cursor is moving all over the clock and each of the values. In this section we have 1, 2, 3, 4, but the cursor is moving not only the uh, general values but also the point values, that means the floating section. But in this picture too we have it have the discrete value, that it means it have only the integers but not the floating numbers. That's why the number 2 is digital clock and this one is the analog clock. Now we will discuss about data acquisition. What is data acquisition, which is known in the short of DAQ, is process of measuring an electrical or physical phenomena such as voltage, current, temperature, pressure, and sound with a computer. That means it is a physical phenomena that helps us to measure the voltage, current, temperature with just a single computer. A DAQ system consists of some sensors, and DAQ measurements the hardware and a computer with the programmable software. In digital data acquisition system, we have the physical system which generates the physical signal. Then we have transducer sensor, which is the noise electrical signal. And lastly we have the signal conditioning, which generates the conditioning of the signal. And then we have analog digital converter. That means the analog signal will be converted into the digital format. Those signals are all are analog instead of this one. That means in this converter section the analog signal is converted into the digital format. And lastly, the digital data goes to the computer and it saves the information about the data, because we all know that computer saves only digital format, not the analog. So that's why we move the data to the digital signal and lastly save it into the computer. Thank you.